Ladies and gentlemen, please welcome Chief Technology Officer, Autodesk, Jeff Kowalski.
Hello, good morning. Hello, good morning, everybody. Welcome to Autodesk University 2012. I am very excited to be here today because this year we're going to do something a little bit different. Usually at the AU General Session, we talk a lot about the future of design and technology. And we're definitely going to do some of that today. But mostly, we're going to be talking about some of the exciting things that are happening right here and right now. Today, we're going to show you a lot of practical tools that can improve the way that you work, not sometime in the future, but right now and today. At Autodesk University this year, we're keeping it real. So let's get started. As you know, at Autodesk, we're tool makers. We make the tools for you guys, the ones who are imagining, designing, and creating a better world. And because we're tool makers, the big question for us is always, which tools should we make? To answer that question, we turn to our vision of what design is, why it's important, and what it could be. Autodesk has shaped that vision over the past 30 years, just as we continue to shape it today, through a global conversation with people just like you, exploring the power and potential of design and technology. We started that conversation way back in 1982 in a tiny office in Sausalito, California, and I'm happy to report that it's still going strong today. Now I'm going to share with you some of our latest thinking about design and technology, because that thinking has a direct impact on the kind of tools that we're making for you right now. To start us off, I'd first like to talk about the power and the limitation of tools. Think for a moment about the impact that tools have had on our success and evolution as a species. This is the oldest existing tool made by a human being. It's 2.6 million years old. It's a stone hand axe. You know, there's even evidence that this tool-making history might go back even further, to 3.4 million years, maybe even older than that. The ability to make and use tools like this is what made us human, and it set us apart from the other animals. But our tools didn't just make us human. They literally made us. They made our hands. And they shaped our brains over millions of years of interacting with them. Our tools have changed the way we think. In fact, in many ways, we literally see the world through our tools, because it's often the arrival of a new tool that opens our minds to new possibilities that we never could have imagined before. New tools not only make it possible to do things, they actually expand our very vision of what we believe to be possible. Even today, our design tools have tremendous influence on what we can and cannot create. Tools might be one of our greatest achievements, but they're also one of the most powerful limitations on our capabilities. When we look closely at the things we create, we can see clearly the traces of the tools, their very features, in the characteristics of those creations. In fact, I know there are many people in this audience who can look at a building or a car or a consumer product and literally tell which piece of software was used to create it. Physical tools, the chisel, the saw, the axe, they all leave tool marks. And digital tools also leave their mark in the things we design. So the good news is that we can conceive and create anything that our tools are capable of, but the flip side is that it's hard for us to think about or do things that our tools are not capable of. The limitations of our tools have always placed a kind of outer boundary on the things that we can conceive and create. And at Autodesk, it's our mission to keep expanding that outer boundary. One of the most important ways for us to do that is through discussions with you at places here, like at Autodesk University. So, let me pose this question to each of you out in the audience. What kinds of things could you possibly conceive and achieve, things that you're not even thinking of right now, if you were able to radically change your tool set and mindset. To give you an example of what that might be like, I want to introduce you to someone who has created a whole new way to get from point A to point B. Ladies and gentlemen, please welcome Dezső Molnár.
Get your motor running. Head out on the highway, looking for adventure.
Morning. Hey, brother. Hey. Good morning. A few years ago, I was trying to find my way out of Los Angeles. It was a very crowded day, and I was stuck in traffic. And I thought, this isn't going to work. So I ended up waiting a while, and I went out that night when there was no traffic, and I blazed down the freeway. And I thought, you know what? There isn't a traffic problem here. The problem is that there's just too many people on the road at the same time. So what I decided to do was think, hey, you know what? I need a flying car to be able to deal with this, but I didn't know where to get one. So here's a photo of something that is really bad traffic. It was worse than anything I experienced. This is after, just before Hurricane Rita. And sometimes what you perceive as a problem, sometimes the solutions are hiding in them. In this case, all you see is headlights. That's because everyone's leaving Houston on their way to Dallas. And what was normally, you know, a 2 or 3 hour drive became a 48-hour drive for a lot of people. So this is something that we're going to see in the future, which is effectively municipalities are going to indemnify themselves by saying, hey, you know what, we got a problem, everyone needs to get out. Well, in this case, the storm killed 7 people, sadly, in town, but the commute killed 120. So this is a really worst case scenario. So I thought, well, you know, as this is happening, I also would like to be able to get out when I really, really have to. So I started thinking about ways to do this. The cities are very crowded downtown. Flying is something that you basically do from a runway, and you'd need one when you land as well. So nobody's going to build long runways in big cities like Beijing or, you know, São Paulo. So I thought, well, we need to be able to land slow. And I thought, well, how do you get out? You're not going to have a runway to take off with. So I thought, maybe the thing to do is when you're leaving, don't bother flying, just drive out. Because you're going from a very congested place to a very diffused place. And so I kind of threw the idea out to myself, which was a bit of an angle at that point. I thought, what if you don't solve the flying car thing by having this thing that hovers and flies in and hovers and flies out? What if you just fly in and you just drive out? So I started thinking about ways to do that. And in London, anytime you see a messenger, a bike messenger, this guy's going to be driving a BMW. He's always slicking between the cars. Here's a photo of a place. I think this is Malaysia, or it could be Spain. If you've ever been to Spain, you'll find that all the motorcycles come to the front at a red light, and they don't even wait for the red light. They're basically asked to get out of the way. Go ahead and drive through the red light so that the cars can get moving through it. Well, this was the approach I thought. Maybe I'll make a motorcycle and use that to get out of town. Well, the cool news is that motorcycles that you see available in a commercial availability, they're basically the offshoots of what's racing. So these bikes here, these are racing bikes. These are the fastest in the world. And these engines are getting more and more and more powerful every year. They're up to almost 200 horsepower now. And it's kind of a Trojan horse because these are the ones that they sell, you know, at the shop up the street for $10,000. But the fact is that it's completely unnecessary to have this to drive down the street. It's way too fast. The things will do 180 miles an hour. But they're getting so powerful now, there's an opportunity there for flight. So I started thinking, well, if you're going to design an airplane, the rule is you start with a power plant that exists, find a way to cool it, and then design your airframe after that. So I started thinking about something as far as flying in slow that I remember seeing in a magazine when I was really young. It was like Boy's Life when I was 5 or 6. And there were gyroplanes, and I didn't know anything about them. But so I started looking into them. And it's an old way of flying. It goes back about 100 years. And in this case, the rotor blade on the top, it's not like a helicopter where the engine's powering it. Basically, as they're moving through the air, you either tow them with a rope or you push them with a propeller, but the rotor blade on top just spins in the breeze. And as a result, you have this really simple thing that's just spinning on a bearing. It's not expensive, lasts a long time. So I started looking into this because they're really cheap. Well, this is a picture from the FAA handbook, which describes rotorcraft. The one on the left is a helicopter, and you can see it's tilted forward, and that's because the engine is powered powering the rotor blade on top. And it basically is going to drag it along. The other one is a gyroplane. It's actually about 15% more efficient because it doesn't need an anti-torque rotor in the back. And that one, the angle of attack of the blade is basically 40 forward, and there's a propeller hiding back in there, and that pushes it through the air. The big difference here is that the helicopter will cost you about $500,000, and the gyroplane will cost you $50,000. So I'm thinking, okay, this might be the approach to something that I can actually afford and do. And so I sat down with a friend of mine who knew nothing about aircraft, a musician actually, and I wanted to work with somebody. You know, the old rule is that you deal with somebody who's kind of an outsider and try to come up with a design idea. And we did this, and we did this, and we did it, and it was really netting zero. But I stuck with it because I didn't want to keep going back to engineering world. And then we sort of did like a Ouija board approach one day, and we came up with something that we didn't want to stop until we actually thought it looked cool. And by the time we came up with this setup, where we had the people in the front, the propeller in the middle, and the engine in the back, we just felt like we were onto something. So at this stage, I said, okay, I'm going to have to build this thing. So I got a hold of a friend of mine, Craig Calfee, who owns a bicycle factory, and he makes carbon fiber bicycles. And he's got a little shop, you know, a little blue roof out by the ocean, very, very secluded spot. And I figured if two guys in a bicycle factory couldn't build an airplane, who could? So I went out there and I spent 7 months with him. And after 7 months, we came up with this bike, which is basically, to me, is a personal aircraft. It's basically the size of the guy that's in it, not much more. And it allows you to fold up all the stuff and take it with you. And I also wanted something that was narrow enough that I could take it in a hotel room with me, because I wanted to do this so I could eventually travel. Anyways, at this point, we took it out, and 7 months after we first started drawing it, we had it flying. And this was in Texas back in like 2005, 2006. And we kept everything quiet, and that was our first flights. So this is the layout we ended up with. Again, we have the person sits in the front. Thanks. And this one, the person sits in the front, the engine's in the back, and then the rotor blades are up there and all the spindly stuff. But I didn't really know exactly how I was going to get the blades on and off. And in this one, you can see we basically have to unbolt it and throw it down and bolt it in. And in this case, we managed to move it to a new situation where the whole thing's just going to fold back, and the blades lay up along the side of the bike. So moving forward, this is kind of the new design that we're pursuing. And you can see how they stow away. It's a problem we didn't bother trying to solve at the beginning. We did it later. And now everything's getting moved into software. So now I can call in and say, hey, this isn't working. Let's reverse engineer this thing, do the whole thing in software. This is the new machine we've been out driving around. It tilts. It basically sits between the cars when we're racing down the freeway, and that's my toy. So as you move forward, obviously, you look at problems. Sometimes the solutions are hiding in them. In the case of that first photo, there's 15 empty lanes in there to drive through, and that's where we're going to head it. Thanks. Good morning.
You sure? Hey, thanks so much, Dejer. That was awesome. At Autodesk, it's our mission to give people like Dejer and you the very best tools we can possibly make. One of the ways we've been doing that is by working from an expanded view of design. Traditionally, design tools have focused mainly on the concept of form. Form creation is, of course, critically important, and it's something we've gotten really good at over the years. For example, take a look at this rendering of a building. It's beautiful, right? It definitely helps to express the design intent, maybe even some emotional impact of what we want to build. But if you think about it, this is still really just a depiction of form. And these days, we've gotten so good at that form creation that we've all but eliminated the need for manual input. Instead, we're teaching the computer to look at the world directly using 3D laser scans, point clouds, photogrammetry to bring real-world scenes like this one directly into a computable environment. But there's much more to design than just form. Today at Autodesk, we've turned our attention to the entire design process, and we've gotten some really exciting results. When we look at design in its entirety, we know that it is also about inspiring the imagination, improving the function of the things that we design and their performance in the real world, It's about the art and science of making things, actually building or fabricating them. And it's also about the process of design and how we pull all those things together. Today at Autodesk, we're focusing on creating tools that address all of these important aspects of design. Let's start with imagination. Usually the design process starts with an idea, something that's inspired in your imagination, and once that happens, the next step is to bring that idea out of your head so you can develop it and share it with other people. In the past, design technology hasn't been very helpful in that imagination stage of the design process. But now we've developed some new tools that can help you capture, develop, and explore even your most nascent ideas. Tools like Autodesk Sketchbook are essentially digital sketch pads that work like paper napkins, only better. And there's 123D Design, which helps you quickly explore your ideas in 3D. And 123D Make, which makes prototypes quick and easy to build. All of these tools taken together are expanding the boundaries of what's possible for us to do in the imagination phase. Now let's focus on function and performance. Think about the difference between what a designer might think about and what an engineer might think about. Engineers don't really focus much on the actual shape or form of whatever they're creating. They focus more on what it's going to do, how it's going to work out there in the real world. Today, we have some new tools that let engineers sketch out and explore multiple functional ideas before having to commit to any single idea. After sketching out functional ideas, the next step is for us to actually experience how that design is going to perform before it's built through simulation. Doing this can be very valuable, and not doing it can be very dangerous and possibly even very expensive. For example, how many of you remember when Microsoft had to recall their Xbox 360 gaming console a few years ago? That cost the company a cool $1 billion, which I understand at Microsoft is a lot of money. The problem started when they didn't correctly simulate or analyze the heat flow inside the product. And as a result, there wasn't enough cool air that was headed to a particular part of the console, frequently caused a part to heat up and eventually pop off. So picture a hardcore gamer, a real Xbox power user fighting some terrifying aliens. At the very moment when he's about to claw, shoot, and sprint his way to the top of the game, to that next level, the part of the console literally pops off, and victory is replaced by the red ring of death. Translation, game over, you're dead. Now, clearly, this was not the experience that Microsoft had in mind for its customers when it set out to design the Xbox. To its credit, Microsoft responded really well to this problem. But the Xbox 360 recall remains a great example of the critical role that simulation plays, or at least should play, in your design process. Simulation can help us better understand early in the design process how a product is going to perform in the real world through techniques like finite element analysis or computational fluid dynamics. And today's simulation is rapidly shifting from a nice-to-have to a must-have. Because today, the things that we're designing are so complex that simulation is a necessary part of the process. For example, let's take a look at a project like the Shanghai Tower, a building which was designed and is now being built using Autodesk software. It's the tall one over there on the right. Now, when that building is completed, it's going to be the tallest one in China and the second tallest one in the world. But the Shanghai Tower is much more than just a building. It's actually a tremendously complex, high-performance structure designed and built to withstand extreme weather conditions in a monsoon zone. To design a safe structure in such a demanding environment, you have to simulate, because you can't do a product recall on a 2,000-foot tall building. Here's another example of the value of simulation. Take, for instance, the work of Dmitry Silikevich. You might remember him from AU 2 years ago when he came up here with me on stage at the general session to talk about his ambitious ideas and projects. Dmitry is a 26-year-old rocket scientist, literally. And these days, he's working on a wild, and some may say wildly improbable, project up in space. His goal is to create a more efficient launch vehicle by shooting a microwave beam at it from the ground, which will superheat the onboard fuel. Basically, he's talking about sending rockets up into space without traditional rocket fuel. Is it going to work? I don't know. But using today's advanced, accessible simulation tools, innovators like Dmitry can explore ideas, even the ones that are arguably irrational, because now he can prove much more quickly than usual whether or not they're actually going to work. This means that he doesn't have to persuade potential investors and collaborators, not to mention passengers, about the validity of his projects with words and enthusiasm alone. Dmitry's story reminds me of a great quote by legendary business thinker Edward Deming, who used to say, "In God we trust, all others bring data." Well, today, even individuals like Dmitry can indeed bring data to discussions about even their wildest ideas. This is really important because the history of innovation shows us that today's breakthroughs are almost always yesterday's crazy ideas. Another way to think about it would be to say that today's simulation tools are rapidly replacing "I don't know" with "let's find out." In addition to the imagination, function, and form aspects of the design process, we also have the actual fabrication or construction of the thing itself. At some point, whatever we've imagined and designed has to be made real. And recent breakthroughs in digital fabrication are radically changing the way that things are being built and manufactured today. So what do I mean by digital fabrication? It's the manufacture of goods designed in software and made by computer-controlled machines. And there are 4 types. Additive manufacturing, like 3D printing. Subtractive manufacturing, like CNC milling and laser cutting. Robotic assembly, and nanobiology, where we're literally designing and making things at the smallest scale imaginable. This rapid, in many ways, radical development of digital fabrication is very important because it's helping us to close the gap between the increasingly complex designs that we can dream up in the computer and what we can realistically create out here in the real world. And now, to bring this challenge into focus for you, I'd like to welcome someone to the stage who is supremely qualified to talk about the opportunities presented by advanced manufacturing technology. She leads a global team of 450 researchers as the technical director for manufacturing and materials technologies at GE, based at GE's Global Research Center. Ladies and gentlemen, please welcome Christine Furstis.
Everybody, there's a shift coming in engineering and manufacturing, and I need you to think about it, be aware of it, and understand how you can impact it. And why is this shift coming? Well, it's because the landscape for markets, for business, for company is changing. And that, in turn, is changing the way companies must engineer and manufacture new products. Why is this happening? Well, for the first time in decades, we're in a material inflationary environment. There's overcapacity in multiple industries, limiting cash flow and leading to a lack of investment. Gone are the days where companies could think about utilizing low labor cost in certain countries to drive their profitability. Yes, it's a new global landscape, so we must innovate differently to be competitive and grow. We're facing what I like to call the third industrial revolution. The need for innovation and embracement of computerized manufacturing. This is how we're going to respond. Because from today's manufacturing semantics and auto generations and simulations, which are wonderful, we need to transform, we need to grow into being able to perform trade-offs, evaluations, and predictions. It's no longer the same world, and we must innovate differently. Every day, products are being produced in factories across the globe. That gives us the opportunity to understand, to gain knowledge, and to learn and harness that information to improve both our processes and products. But until we embrace that the integration of design and manufacturing is the key to growth, we're going to continue to simply work the same way we do today, perhaps only a little faster and with some better tools. I need you to drive a new paradigm and define this third industrial revolution. Companies like Autodesk, they get it. They're working with multiple industries, and they're working to not only define the next set of tools, but also the next wave of engineering and manufacturing mentality. You know, due to the significant IT advances, product development times are getting shorter and shorter and shorter every day. Yet we're still working in the same paradigm for manufacturing. We're handing it off with traditional manufacturing techniques and tools. We have to change this. We have to think about design and manufacturing as the innovation process together. We need to be thinking differently. We need to be more non-sequential and more collaborative. How do we move from an experience-based innovation to knowledge-based innovation? And what sort of development and software skills, tools, and processes will that drive? Well, digital, additive, 3D printing, this technology in manufacturing epitomizes this change. As we build up new types of parts, new configurations rapidly that have features that we haven't ever previously thought were producible in a very repeatable and cost-effective way, not only are we switching from design-defining manufacturing needs to manufacturing capability enabling designs. In addition, we're embarking on a very, very unique journey in this technology. And the reason that this is so unique is because traditionally, when you define a design, you assume that you're using a certain material, and this material has some properties. It's so strong and it's so stretchy. It may respond at different ways when you put an electrical impulse on it. But in additive or digital manufacturing, not only are we specifying the way that the product is going to be built up, but when you're working with materials like metals and ceramics, as you put each layer down, as you create your product, you're actually creating the material properties. You're no longer starting with one part that you machine away. You're building not only the part, but you're building the properties. Think about that journey. How fast you do it, how hot you make it, the way that you put it down, what that layer you're building on looks like, they're all going to impact not only the product, but the final material. So, you know, on one level, it's like we're starting from scratch. The virtual world is now collaborating with the physical world. And with it come not only new risks, but also new possibilities for what we can do together. And to me, that is what's the most exciting word, together. For new movements, such as digital manufacturing, are going to require a new ecosystem, new ways of interfacing engineering and manufacturing, and new players that are joining the system and working together in new ways. Digital manufacturing is where prosumers meet. Professional industries driving one set of needs, and consumers driving new potential solutions. Tools and analytics are going to bring them together to drive growth. Well, there we go again with that word, together. The new collaborative manufacturing supply chains will comprise a diverse and in many cases totally new group of technologists. Machine manufacturers who need to accept our designs and translate them into a manufacturing process. People who will work on those machines and service them and supply materials and controls, who are now playing in a new field. And specialized software developers to help us take the learnings from one set of materials and parameters and extend it to the next. With an ecosystem, we have knowledge and the capacity to accelerate our understanding of products' feature, process, property relationships. The virtual world is collaborating with the physical world, and with it come those new possibilities of what we can create. We're transitioning from the design driving manufacturing needs to manufacturing capability, opening up design possibilities. And like the early stages of any revolution, we're still figuring some things out. The big question is, how do we think differently about design and take advantage of these new capabilities being opened by the digital world? How do we incorporate this new set of tools that provides us with more data and more capabilities to enable new products that couldn't previously be considered? GE, like others in this field, are trying to find our way in this new landscape. Software and analytics are going to be key enablers and accelerators, because right now, progress is incremental. In 3 years, we're going to be putting a jet engine into service that has 3D printed parts. That's a good start, but we're thinking much bigger than just a few parts of an engine. Today, and increasingly in the future, the industrial world is embracing the power of computing, software, and analytical tools to both accelerate the innovation process as well as revolutionize what we're able to create and build. Put another way, we're bringing software engineers to the shop floor. Join with me in moving manufacturing from experience-based innovation to knowledge-based innovation. Thank you.
Thanks so much, Christine. The last facet of our expanded view of design is managing the process. I think that process management has traditionally been underserved in terms of good digital tools, and I bet most of you are going to agree with me that technology could certainly do a better job of improving the design process. But recently, we've made some exciting advances in terms of connecting all of the tools and data you need to do your work. And in a few minutes, Carl Bass is going to come out and show you some of the work that we've been doing. Those are the 5 aspects of design that we're focusing on right now. We believe that working from this expanded view of design helps us to create tools that give you the widest range of capabilities. And just as holding that first human tool must have changed ancient man's view of the world, I believe that these tools in your hands will expand what you can conceive and achieve in this world. Okay, so we've been expanding our view of what design is, but we so far still haven't mentioned the most important element of the design process, and that is you. When we look carefully at the entire design process with all those tools and technologies and workflows, it's easy to see how the actual people doing the work can sometimes get lost in all that excitement. And I know at first glance that focus on the people might sound kind of obvious, but when you look at the history and the context around design software, it's actually a pretty profound insight. Because in the early days of design technology, we all focused a lot on just the tools required to do digital design. And then when we had the tools, we turned our attention to the data that we could create using those tools. But today, I think it's important that we finally include the people and the teams who use those tools and create that data. This focus on people and teams is already yielding compelling innovation, some of which you're going to see this morning here, and of course, throughout your week at AU. So far today, we've been talking about the need to consider all the different aspects of design, including the real human beings at the heart of the process. And that's great. But for that insight to really matter, for it to really pay off, the tools, the data, the people, the teams that we've been talking about, they all need to be connected. Which leads us to an interesting question. How connected are you today? I would guess a lot. And also, not at all. In fact, I think most of us are suffering from a curious condition known as connectivity schizophrenia. Here are some of the symptoms. In our personal lives, we live in an extremely connected world. But in our professional lives, we work in an extremely disconnected world. Think about it. Something happens in your personal life. Let's say your daughter hits a home run. Within 5 minutes, everybody knows about it. A whole community of people instantly informed, even though they might not even be interested. But in your professional life, if someone on your team makes a critical change to a project, it's very likely that you won't know it's happened until someone tells you about it later in a meeting or in an email. Am I right? That's connectivity schizophrenia. So how do we address this curious condition? How can we stay connected to all the information and people we need to do our work? We do it with a whole new set of cloud-enabled tools. But before I talk a bit about that, I'd like to talk a little bit about the cloud. You know, we've all been hearing a lot about the cloud lately. But a lot of what we hear completely misses the point about what the cloud really is. For one thing, the cloud is not just some kind of great hard disk in the sky. Yes, it is an infinitely elastic computing resource, but it can also serve as a single point of connection, a central coordination place for everything that we need to know and do to complete our projects. One of the greatest benefits of the cloud is its ability to replace that dead air between us with an always-on connection, a connection that goes far beyond just the potential for communication. For example, think for a second about your corporate directory. All those emails and phone numbers, they don't really connect you to your project team. You can reach all of those people, but you're not really connected to them. What we're bringing you today is true connectivity. We're giving you persistent awareness of what's happening right now on the project, robust context that helps you see the big picture, and the ability to look ahead, spot potential problems, and address them productively. When you have true connectivity, your projects and your teams move forward together. So today, we've talked about working from an expanded view of design, one that looks at the whole design process, focusing on people and teams and what they really need to do the work, and connecting all the elements of our projects through the power of the cloud. This is the vision we've used to create the next generation of design tools. In a few minutes, Carl Bass is going to come up here, and he's going to literally put these tools into your hands. But first, I'd like to introduce to you a very special customer of ours. He's not our biggest customer, but he has spent a full third of his life obsessed with the challenges and the pure fun of engineering and making things. And I think you're going to be inspired, as I am, by his unique perspectives on design. Ladies and gentlemen, please welcome Skylar St. Ledger.
is Skylar St. Ledger, and I love to make things. I'm here to talk to you about why I'm a designer and a maker, and why the world is on a path to make designing ubiquitous. Let's start with a look way back in time. Leonardo da Vinci was a prolific inventor. The design tools of his day were a sharpened piece of charcoal and some rudimentary parchment. But he struggled to go from a pencil sketch to a working prototype. That's why you never saw a helicopter in the 15th century. Let's fast forward to the 19th century. Advances in technology enabled Thomas Edison to bring his ideas to life. But contrary to popular belief, he didn't actually invent the light bulb. He only improved on Humphrey Davy's 50-year-old idea. The true genius of him was that he designed and tested thousands of different filament designs. Design and test, over and over again, until he landed on the one that provided adequate luminescence combined with bulb longevity. So why am I talking about his design process? Well, the world is a different place, and there's some really, really interesting things that had happened that could change everything. Let's take a moment to reimagine Edison in 2012. If Edison were alive and inventing today, he would use a 3D CAD tool like Autodesk Inventor. He'd post his design files to Thingiverse, where they could be quickly iterated with crowdsourcing. He'd use Instructables to document his work, and he'd manage his IP with Creative Commons. And to fund all this, he'd have a Kickstarter campaign with various Friends of Edison financial support levels. In fact, a few weeks ago, I saw a Kickstarter project, The Light Bulb Reinvented. Could Edison be back? But I'm getting ahead of myself. Did you know that today is Bill Nye, the Science Guy's birthday? Are there any Bill Nye fans out there? Well, I'm a big fan of him. And in honor of him, I would like you to consider the following. Point 1, computing is ubiquitous. In the 1970s, a computer was as big as a whole room and only used by serious people with lots of letters after their names. Are you one of them? I got my first computer when I was 4 years old. Now I have a variety of desktop and laptop computers, as well as a tablet and a smartphone. The point is that kids today have access to computing power that in your day was referred to as supercomputing. We can crunch numbers, design amazingly complex objects, and run system-level simulations, all from the comfort of our keyboards. Point 2, the internet has transformed everything. Kids like me have grown up with the web. We have never known a world without the internet. Google has been my best online friend since I opened my first browser window. You know how kids ask their parents thousands of questions like, why is the sky blue? Or, what's the 8th decimal place of pi? Well, instead of asking my parents, I just Google it. The web is a gateway to anything and everything. I learned how to knit at knittinghelp.com. I learned how to program Arduinos at ladyada.net. And I got much better at using Autodesk Inventor by watching John Helfand's YouTube tutorials. It's no longer a question of living in the right school district, but having a fast broadband connection and the desire to learn. By the way, if any of you work at CenturyLink, I could really use a fiber drop to my house. See me after my talk. And in case you're wondering, the 8th decimal of pi is 5. Point 3. Fabrication tools are becoming personal. The first 3D printer was invented in 1984 by Charles Hall. Like the 1970s computers, they were big and expensive and only used by big companies with big budgets. Just 10 years ago, the cheapest 3D printer would set you back at least $25,000. Today, you can get a 3D printer for as low as $500. Thanks to Autodesk and Google, you can get introductory CAD software for free. You can get a personal laser cutter or small CNC machine for a few $1,000s. Now let's take a look at the developments in the area of electronics. There are a large number of options from 8-bit microcontrollers like the Arduino, to 32-bit mini computers like the Raspberry Pi. But hardware is only half the story. The low cost and ease of programming has made these devices pervasive in many designs. I recently found out that you're not supposed to learn how to program microcontrollers until your second year of electrical engineering courses. But since no one told me, I went in and taught myself anyway. Like Edison, I can dream up ideas and bring them to life. I can take a new design and turn it into a first prototype within hours. If I need a bigger tool like a CNC machine or a laser cutter, I can go to my local hackerspace and use theirs. Fab houses enable me to scale my production in days. The speed at which ideas hit the commercial market has been shrunk by several orders of magnitude. Are you prepared for competition that moves at this speed? Because that's what my generation is already doing. So put all of these factors together. 1, computers. 2, the internet. And 3, personal fabrication tools. And you can clearly see the democratization of the design process is complete. I'm in middle school and I'm a designer. Imagine what I'll do when I get to college. I can't wait for the future. Thank you. Now I'd like to introduce all of you to Autodesk's Maker-in-Chief, Mr. Carl Bass.
Hey, Scott.
Hi, Mr. Bass. That's a cool lab coat you got there, but can yours do this? Lights, please.
Well, that's pretty good, Skylar. Let me see what mine can do.
Well, mine can do this. It has an accelerometer in it, so it changes the lights according to how I dance.
Okay, you win.
Now I'm going to need your lab coat to show how it was made at the Creative Studio.
Okay, you going to take it for me?
Yep.
Okay, thanks.
You're welcome.
There you go. Thank you, Skylar.
Thank you.
Pleasure. So by the way, if you ever want to know where young engineers come from, there you go. And if you want to know more about the lab coats, Skylar's going to be around all week. You can go talk to him. He's going to be taking classes along with everyone else, so you can hook up with Skylar. They're also putting an Instructable up about it, so you can read about it there. I'm also happy to welcome 120 high school students. There they are. So there's 120 high school students from Clark County who are joining us here at AU today. And I think one of the important things, I think it's really important to hear from young people. You know, young engineers like Skylar and the students from Clark County, because I think it gives us a heads up on where things are going and how they're thinking about things and how they view the world so differently than we do. And it's a way to just spark our imagination. So what I'd like to do now is share a video with you from a slightly more mature, well, mature might not be quite the right word, let's say a slightly older engineer, a really good friend of ours, our friend Saul Griffith from Other Labs. Like Skylar, Saul has a really interesting perspective on engineering. Let's take a look.
Wouldn't it be cool if, that's what defines a real engineer for me, it's someone who constantly says, wouldn't it be cool if? My niece wanted an inflatable elephant, so I made an inflatable elephant, essentially a Macy's Day Parade thing. Then once you build it and you have an inflatable elephant, you're like, wouldn't it be cool if this elephant could walk? How would we do that? And we've figured out some actuators and ways to sew these actuators onto this inflatable elephant. All of a sudden we had a walking inflatable elephant. Oh, that could actually be really useful for doing human-safe robotics or soft prosthetics for more comfortable medical devices for spinal cord injuries, victims, etc. Very low mass, low inertia robots that are extremely efficient energy sense for doing tasks. All of these applications come to you. No one was thinking about revolutionizing robotics. If you're going to create something new, it's because you think you can make something cool or they want to save the world, and I'm going to put both of those in the same bucket. I really don't think engineers understand how big their influence is on the world. Everything around us, every single object has the hand of the engineer in it. And more than ever before in history, we understand the consequences of how we shape the world. I think it's really important to encourage the next generation engineers that they are allowed to think outside of the traditional boxes. So in the 1950s, to be a product engineer was just listen to the client, build a product. But we didn't really understand the downstream effects of that. The reality is now we can see the disparate effects of small decisions. How do we redefine an engineering ethics where, for example, the environment is a stakeholder and considered equal with the client? First step is become literate in these downstream effects. If you don't understand those things, I don't think you can design a good product for the 21st century. You'll just be doing what everyone did 30 or 40 years ago. I don't really know engineers who grew up thinking, you know what, I want to destroy humanity. I haven't met the Dr. Evil of engineering yet. It self-selects for pretty positive, optimistic people. Let's give them even better tools and more freedom to express their optimism in the products that they're designing. From redesigning what toothbrushes are through building entire working machines that have no hinges, no joints, no bearings, no servos. And there's a lot of hope that a lot of those machines will be more energy efficient than traditional machines. So this is sort of challenging previous notions of mechanical engineering. Is it practical? Maybe, but it's certainly at least exploring new potential directions. You're living through a transformative time, probably more transformative than the Industrial Revolution was. We have an unprecedented democratization of tools. Laser cutters, 3D printers, water jets, CNC, everything. Things like makerspaces. It's getting easier and easier for people to make real their ideas, and then you throw that out to the public and, and see whether it sticks or not. There's no reason not to pitch your exciting visions for the future in a much more entrepreneurial way. Keep moving, keep having ideas, and allow yourself to be frivolous sometimes. Just make sure you're doing something. Treat every single thing in your life as a little engineering design problem, and do it so many times that over a lifetime you become like a master. And they can be silly things. Dream about how to make your shower head more efficient while you're showering every morning. But you also have to have the discipline to do a lot of it with real rigor, like understand the physics and the math and the mechanics and the kinematics and the controls underlying all these things, so that when you get the right collision of ideas, that may be the thing that changes the game. So really, this is awesome news. We absolutely can design a really cool world to live in. You can use your engineering as the hammer to hit every nail.
You know, I love that video because it just shows us the huge impact that engineers and designers can have on the world, especially when they ask that really all-powerful question of, wouldn't it be cool if? And that's what I'm going to do right now. Ask a bunch of what-if questions about the things that we're all trying to do in our day-to-day work, and how we can do them better and faster and easier. So Jeff talked about how we're broadening our view of design so that we're looking at the whole process, and how we've been busy building this next generation of design tools. Now, what I'd like to do now is take the time and show you some of those tools and how they're changing the way you can get your work done. I think you'll see today that the answer to what if is often, I can. So let's start at the very beginning. When you need to get those initial ideas out of your head, we've all sketched on napkins from time to time. But what if there was a better way to capture your ideas the moment they hit? What if you didn't need to use napkins anymore? And in fact, you don't. Sketchbook lets you quickly capture your ideas, whether it's on an iPad, or it's an Android tablet, or it's on your smartphone. And you can do this wherever and whenever you want to. Now, more than sketching just form, what if you could actually sketch function, so that you could quickly understand the forces that are involved in your design? Now, force effect motion lets you do exactly that. Now, one of the things about this is you certainly can start from scratch, But what I love most about this app is combining new capability. It's the ability to take a photo of something you see, a bridge or a machine, and use that as the starting point to see how it works. So for mechanical assemblies of all kinds, this makes it easy to understand how the mechanism works well before you're doing a detailed design. Now, you can also do the same thing for buildings. With this new product called Form-It, you can quickly block out a structure in place exactly where it's going to be built. So you can get a sense of the sight lines and access and how your design will relate to the environment and to all the adjacent buildings. And as you try it out, information comes back like the amount of square footage gets tracked in real time. So what Form-It does is it lets you quickly try many different options and see how all those choices, how they relate to the project's requirements. Now, let's talk a little bit more about function, but this time let's use a civil engineering example. Let's say you're designing a long section of highway. Now, what if you could actually model your design in the context of the real world? What if you could access all of the information about the terrain where the highway will actually be built? And what if you could think about designing miles of highways, not just short sections? So with Infrastructure Modeler, you can do exactly that. You bring together all kinds of different data, 2D data, GIS data, raster data, and 3D models. And you can virtually drive on the road before it's built. It allows you to experience the design before it's real. And based on that experience, you can improve the design. You know, the result of building in context this way is that you end up with a road that is safer and more efficient, and you end up with a project that is better planned and better executed. So this is the next generation of infrastructure design. And this year, you'll see a lot more coming in the area of civil engineering. And as you just saw, understanding how your design is going to perform once you've built it is important. Now, in the past, simulation was usually too expensive to implement and too difficult to use. I mean, it was so much so that it wasn't really practical for that many people. But what if simulation didn't require a huge upfront investment? What if it was so easy to use that anyone on your team could be running useful simulations in minutes? You know, what if you could actually run the largest data sets, larger than anything that your current workstations could handle, and you could do it right now? And what if you could run those simulations from anywhere, on any device? Well, today you can. One of our most exciting new offerings is Simulation 360. Easy to set up and easy to use. You know, when it comes right down to it, we think simulation should be a part of the process, not the end of it. Now let's take this a step further. Imagine that you had all the computing power in the world, and this computing power was basically free. How would you design differently? What if instead of doing one simulation, you could do dozens or hundreds or even thousands of them? Well, today, you can explore many options much more quickly. You can explore them so that you can find not the first design that works, but you can find the design that works best. So here's an example of the power of simulation. Did you know that in the United States, 1.7 million people get hospital-acquired infections every year? So knowing that, if you were designing an operating room, wouldn't it be amazing if you could simulate and visualize airflow and get rid of the dirty, germ-laden air as effectively as possible? With Simulation CFD, you can. Easy to use, easy to visualize, and it gives you compelling results. And it clearly shows what's going on. This kind of tool makes it easier to make good design decisions, which in this case actually saves lives. Now, what if in addition to seeing how your design was going to work, you could also see people interacting with it? For example, what if you could simulate how well your hospital design would handle crowded hallways or intersections during periods of high traffic? Geppetto lets you put virtual people into your designs so you can watch them respond to the digital environment and respond to each other. So let's move from how something works to how something looks. What if you didn't have to treat the resources needed for high-quality rendering as scarce? What if you could present all of your ideas to your clients with stunning realism? Well, now you can. Now, photorealistic rendering isn't new, but with our new visualization service, we're making it easier and more affordable. The service handles all the materials and lighting for you, and you don't need all of the rendering hardware, because instead of having to buy it and maintain it, we give you access to all the computing power you need when you need it. And all of this is accessible from inside the tools you already know. Now, let's take a look at modeling tools. Let's face it, the reality is that every one of us uses multiple tools, and these tools don't always connect as well as we'd like. And there's nothing more frustrating than having your data trapped with your tool. But what if you could open a Pro-E file, a SolidWorks file, a Rhino file? No exporting, no importing, and certainly no ending up with a tessellated mess. What if you could not only open all those files, but you had access when you did to all the real underlying geometry? And what if all the translation just happened magically? It happened automatically and just worked. Now, what if you could use the best tool for the job when you needed it? You know, the ability to move as fluidly between digital tools as we do between shop tools. You know, if you could use surface modeling or solid modeling. What if you could model parametrically or use direct manipulation in the same application? And what if you could just model in whatever way was appropriate, whether you're doing industrial design or mechanical design? Well, all of that is possible today. I'm very happy to announce here at AU for the first time, Fusion 360. Fusion 360 is the world's only complete 3D CAD solution that lets you work the way you want to. It reads data from multiple sources transparently, and instead, it helps you manage your data instead of creating a data management problem. And you can use it as much as you want or as little as you want, and you only pay for what you use. Now, Fusion 360 is very useful to us as individual designers and architects and engineers. But most of the projects we do involving working with other people and involves working with large teams. So what if you weren't limited by your own expertise? What if you could leverage the ideas of all the smart people in your network, all the other experts, to help you solve your design problems every day? With Fusion 360, you can invite people into your community, into your projects to inspect your designs and suggest solutions to your problems. Now, Jeff also talked about digital fabrication as one way we're closing the gap between what we design and what we make. And that's great. But what if digital fabrication was much simpler? What if CAD and CAM were finally connected in a useful and practical way? And what if you could just hit print for a 3D object, the way you can for a Word document, whether you're using a water jet or a CNC machine or a laser cutter? So today we're developing tools that streamline the steps to get from your digital models to a tool cutting through material. It's making digital fabrication more practical than ever. Now let's talk about processes and about managing these complex projects that we're all doing today. All kinds of issues come up when you're building and manufacturing the type of projects you're all engaged in. Now what if you could see early on in the process all of the problems that were likely to crop up? For example, what if clash detection was easy? Now that's great. Clash detection is useful, but what if we had clash resolution? The old way would have been to send an email about the clash to someone. But now you can send the actual clash with all of the context and all of the components involved. That way the person that needs to fix the problem has all the information that they need to resolve it without any back and forth. Now, Jeff talked to you about being connected to your tools and to data and teams. And even though we've had rich 3D models for a really long time, they've usually been locked away on the desktop, and only designers and engineers really had access to them. But the reality is that lots of other people need access to that information as well. All of the stakeholders, customers and contractors, even when they're out in the field. So what if you could give everyone who needed it access to the data that matters, anytime, anywhere, and on any device? So what you're looking at is BIM for everyone. Now, one of the great things about BIM is that it provides you with a complete list of all the components used in your design. But wouldn't it be great if we could really access that list while we're at the job site? Has it been ordered? Did it arrive? Was it inspected? And what if you could make easy updates to all of this? BIM 360 Field lets you find and track all of this stuff to make sure everything is right. It brings the power of BIM to the construction site, so now we have BIM in the field. And here's another reason why being able to manage the design process is so important today. We're working in increasingly distributed teams and working with increasingly complex supply chains. Now, the traditional technology solution for this problem was PLM software. But legacy PLM software is terrible. You know, it's huge systems that are expensive to implement and almost impossible to maintain. What's even worse, you need to change your process to accommodate the way the software works. And that's why people spend so much and get so little from traditional PLM. But what if you could be up and running with PLM in a matter of days instead of years? And what if there was a PLM system that adapted to the way you work instead of you having to adapt to the way it works? And what if you could adopt PLM in your company one process at a time? Well, today you can. Autodesk is bringing you PLM you can actually use. In fact, it's the fastest growing PLM solution ever released. Easy to deploy, low cost of ownership, and you can use it when you need it and can adopt it one process at a time. You want to start with procurement? Great. You want to add quality control? No problem. It's not all or nothing. It's a real-world, usable technology that will help you bring better products to market more quickly, more easily, and more cost-effective. So today I've talked about some of the tools and technologies we've been working on. And as we said, we think that one of the biggest opportunities around is connecting our tools, data, and people. So what if there was just one place where you could go to do all this stuff? Everything I just showed you. A single point of connection that you could log into from anywhere on any of your devices, which would give you a single source of truth and all the updated information that you needed. Well, that place is Autodesk 360. It's the connective tissue. It binds all of this together. It's the hub. A360 gives you the ability to search and translate and view all the information in your projects. It allows you to communicate with all the other people involved. It lets you store all of the data related to your project in a single place that's accessible to you wherever you need it and whenever you need it. So what it all adds up to is a coherent, connected experience built on a shared backbone of data and web services. Now, I want to shift my focus from the apps to the underlying technology. All of the tools that I showed you this morning are powered by the cloud. In fact, they're really just distributed apps. They combine the power of the cloud with the capabilities of the device in your hands. And that doesn't matter whether the device in your hands is a phone or a tablet or a notebook or a desktop. This new architecture, this cloud architecture, is the biggest thing to happen to computing since the personal computer. So from conceptual design to simulation, to taking information to the factory floor or out to the construction site, all of this can be done with our tools today, right now. In fact, we're the first company to bring you a full set of professional-grade tools that are cloud-enabled, that span the entire design process. And you know, it's funny. Even today, people are saying that what I just showed you is not possible. You know, there's these cloud skeptics. They say things like, modeling in the cloud is impossible because it's too graphics intensive or too bandwidth intensive or too compute intensive. But today we showed you Fusion 360, a full-featured, cloud-based CAD program. They say you can't do real simulation in the cloud. But today we showed you Simulation 360 and Simulation CFD, where you can not only do simulation, but you can do optimization. And some people still believe mobile devices like tablets and phones will never play an important role in the design process. But you can take virtually every part of your work with you on the devices you have in your pockets right now. And the stuff isn't theoretical. Our customers have already been using it. For example, they've rendered nearly 1 million jobs, logging more than 3 million CPU hours on A360. In October, AutoCAD WS reached 10 million downloads. Our BIM 360 platform has more than 40,000 users, and Simulation 360, which just launched in September, has run more than 17,000 jobs have been run on that platform. And PLM 360, which is the industry's first and fastest growing cloud-based PLM solution, is now being used by more than 350 companies around the world. You know, I think those numbers are pretty real and pretty impressive. Now, I know that some of you have concerns about the cloud and about mobile devices. But think of it this way. You may not be using cloud or mobile in your professional life, but I am almost certain you're using it in your personal life. And that's whether you do online banking or file your taxes electronically or use Spotify or Facebook or Amazon. So I understand that you have concerns. With each new way of working, there are certainly new issues to consider. But the great thing about this next generation of tools is that you don't have to embrace them all at once. Not at all. We've built them to complement the way you already get your work done, and you can adopt them one at a time at your own pace. So for example, if you want to use Revit on the desktop and render in the cloud, that's fine. You want to try Fusion 360 on your existing project data? No problem. Or you want to use desktop tools for modeling and documentation and then use the cloud for PLM, you can do that right now. It's all up to you. And so I'd like to leave you with one final thought. Jeff talked to you about the power and the limits of tools. And as tool makers, we see it as our job. In fact, we see it as our obligation and our promise to you to develop tools that allow you to maximize your creativity, your imagination, and your skills. It's our job to make tools that make you as productive as possible. So when you go home after AU, the next time you find yourself asking one of those what if questions, we want you to be able to say, now I can. All of this is real and available to you today. So the next generation of design tools are here to empower you and the next generation of engineers like Skylar. Thank you, and have a great AU.
Ladies and gentlemen, please welcome technical evangelist Autodesk, Lynn Allen.
Thank you. Wasn't that great? Oh, it was fantastic. Well, I would also like to welcome you to our 20th annual Autodesk University. Can you believe that it's been 20 years? I'm actually kind of curious, how many of you have been to more than 10 AUs? Make some noise. That's pretty good. Well, believe it or not, I have been to every single one. In fact, at my first one, I was about the same age as Skylar. I really can't believe how the AU experience has changed in such wonderful ways, but one thing that really hasn't changed is the energy and the excitement. Autodesk University first started in San Francisco, and now we have gone global. This year, we held AU events in Japan, Russia, Brazil, and Germany, and next month, we have AU China. And AU isn't just global, it's virtual, with thousands participating online through AU Virtual. So we have a wonderful week planned for you. For starters, there are over 800 classes this year, which is a new record, and I'm sure that many of you had a very tough time deciding exactly which of all those classes that you wanted to attend. Well, right now, I'm going to make your what to do decisions even a little bit harder by giving you some other options to choose from this week. First, you have got to check out the innovation forums. Let's take a look.
At Autodesk, we're excited about the future. This year, we bring together today's visionaries in a series of 6 innovation forums. Join us as they tease apart current trends and answer the big questions of tomorrow. It's time to put emergent technologies to work, because the future is now. The cloud. It's here and it's working for millions, but are we clear on its challenges and opportunities? Manufacturing. What are the implications of robotics, new materials, and 3D printing for both the big players and the nimble startups? How is design shifting into the hands of consumers? Easy-to-use tools empower people to imagine, design, and create for themselves. But where is this DIY movement really heading? It's the year 2025. What does life look like? What will we design in a world that's more turbulent and chaotic? How will today's germinal technologies become the norm and shape our everyday lives? How can designers push new technologies to tackle the big challenges? Sustainable water, renewable energy, better education. What can designers learn from each other? Participate as 4 industry leaders crowdsource solutions to deliver healthcare in underserved locations. What's certain is the rate of technology, design, and innovation change is so fast, it's already here. At Autodesk, we are moving boldly forward, and we hope that you'll join us.
So last year, the innovation forums were all the rage. And if you went to even one of them, you know exactly what I'm talking about. So I encourage all of you to be sure to put at least 2 innovation forums on your schedule. Or if you're an overachiever, I suppose you could go to all 6. You will not be disappointed. In addition to the classes and the innovation forums, you're going to certainly want to spend some time in our amped up exhibit hall. It's filled with all types of exciting technologies and exhibits. In fact, this year, we have more exhibitors than we've ever had at AU. Here you'll find the Autodesk Gallery at AU, which features some of the finest work from our most innovative customers. The exhibit hall is a great place to try out the latest and greatest software and hardware. And then, of course, there's my personal favorite, the International Community Pavilion, where you'll find the Augie booth, and you can also test your technical expertise by participating in the Augie Top Dog contest. And now I would like to give a big shout out to our platinum sponsors, Dell, HP, Intel, and Lenovo. Let's give them a great big round of applause. And our platinum sponsors invite you to their technology showcase tomorrow night. I'm hosting this exciting event, and I expect all of you to join me there. After relaxing with some cocktails and appetizers, we're going to learn all about how their emerging technologies will be radically changing the way that you work. And I definitely want to see you there. After the showcase, I'll be heading over to the compelling, challenging, and often comedic Autodesk Ideas cage matches. Here you can experience great feats of cerebral strength and nerves of steel as combatants defend their ideas against worthy opponents. So go to the cage match event and spur on, or some of you might prefer to heckle, leading thinkers, designers, and engineers. No PowerPoint slides, because let's face it, you're probably going to have your fill of PowerPoint by the end of the week. Just gutsy idea fighters in a ring. Plus, you get to choose the winners, and there are free drinks for all. So what's not to like about that? So how many of you are already using the mobile app for AU? Good. Good, good, good. Yes, it certainly comes in handy, doesn't it? I've been lost twice, and my app saved me. The AU mobile app will keep you in the loop regarding all of the various AU activities, providing information regarding your classes and keeping you up to date on all of the AU news. And you can also use the app to see videos posted on SocialCam, the great social media platform that is the newest member of the Autodesk family. And also, since networking is one of the key reasons that many of you attend AU, you'll find that you can take your networking activities to new heights with the mobile app. Download it today at autodeskuniversity.com if you haven't already to get the most out of this year's AU. And remember, certification is free at AU, so be sure to take full advantage so that you can add certification to your resume. And last, but certainly not least, since this is our 20th year, we're hosting a customer appreciation party on Thursday night at the Hard Rock Hotel. That's right, it's all about you. After a week filled with intense learning, it's going to be time for all of us to do some partying. The customer appreciation party will be the perfect way to end our week at AU. So thank you so much for attending Autodesk University, and let's make this the best AU ever. Thank you.
It's something you're born with and inspires the things you choose to do. You do what you do because it matters. At HP, we don't just believe in the power of technology. We believe in the power of people when technology works for you. To dream, to create, to work. If you're going to do something, make it matter.